Hello and welcome to the lesson on skill number 28. Geometry Unit 5, skill 28. I can apply theorems about the circumcenter, incenter, centroid, and orthocenter of a triangle. In the last lesson we learned the four centers of a triangle and how to construct them. And in this lesson we're going to learn theorems about the centers of a triangle. Started my notes on page 05-11, title it Triangle Center Theorems, skill number 28. And as you can see on the page, I have created three trifolds. Sorry, these are bifolds. A little piece of paper folded down the middle. The first being Circumcenter Theorem, second incenter theorem, and third centroid theorem. Up here we have the circumcenter theorem, which says that the circumcenter is equidistant from the vertices of a triangle. So once we have constructed the circumcenter by finding the perpendicular bisector of each side, we find that the circumcenter is an equal distance to each of the three vertices, which means that PA, if it were 10 inches, then PB would be 10 inches and PC would be 10 inches. This allows us actually also even to use the circumcenter as the center of a circle to circumscribe our triangle. And as a reminder, the circumcenter does not necessarily have to be inside of a triangle. The next triangle center is the incenter, which we found by bisecting the angle. So we find the angle bisector of all three angles, and they meet at what is considered the incenter. This incenter has the unique property that from the incenter it is equal distance to the edges of the triangle. So from incenter to Y could be 5 feet, P to X would then be 5 feet, and P to Z would be 5 feet. The incenter also allows us to create an inscribed circle inside the triangle. The third center, the centroid, is located 2/3 of the distance from each vertex. So if we had this line here and it was 30 feet long, then the incenter would be 2/3 of the way to 30, so 20 feet along that line segment. The centroid doesn't do anything for us as far as drawing circumscribed or inscribed circles. However, it does give us the point that is the center of mass for the triangle. So if we had a triangle and we wanted to hang it from a string, we would want to latch the string onto the centroid to have the triangle be perfectly balanced. On page 5-12, I have included two examples. The first one uses the Circumcenter Theorem. We're given that point P is the circumcenter of the triangle ABC, and that PA is 2x plus 12 and PB is 5x minus 3. Because it is the circumcenter, we know that PA is equal to PB, and we can create an equation using that knowledge to solve for our variable x. Once we know x, we can plug it in and find the length, and consequently that gives us the length of all three of those segments, PA, PB, and PC. Example number 2 says that R is at the incenter, which means that the distance from R to each side is identical. So RA and RB and R, if we label that point C, RC would all be the same length. And in this case, that length is 12. All right. Finally, example 3 has to do with the centroid. And one possible question that you will receive on a skill test and in the post-test on the unit is to find the centroid when given 3 points. We are given 3 points here. Please find the centroid. Because the centroid is the center of mass, it makes sense that it's located at the average of the coordinates. The average of the x-coordinates, 7, -6, and -8. And the average of the y-coordinates, 5, 16, and -9. So we just average those 3 spots, those 3 coordinates. Here's the average of the x-coordinates. Here's the average of the y-coordinates. And we reduce it. -7/3 for x and 12/3 for y. That gives us the location of our centroid. One final example on how to use the centroid is drawn here in example number 4. They tell us that the length of B to E is 30, and they want us to find BP. So if the total length is 30, then what is 2/3 of that length? Well, 2/3 of 30 is equal to 20. So this is a length of 20. I gave one more example under example number 4. AP is 40, so it's possible they'll give us the 2/3 piece and we need to find the 1/3 piece, or find the whole distance, A to D. So if AP is 40, we could say that that is equal to 2/3 of the whole distance, AD. And find that AD is then equal to 60. And if that's the case, then PD is equal to 20. Alright, that concludes the lesson on skill number 28 in geometry. On this skill test, we will need to be able to use the Circumcenter Theorem, the Incenter Theorem, the Centroid Theorem. I didn't go too deeply into the orthocenter because, for all intents and purposes, there is not a lot of practical uses for the orthocenter. So we'll come back and talk about the orthocenter in a later lesson, but for now we're going to leave that one off the skill test. All right, thank you.